Hi, this is Alex from devstories.eu. Astropy, Python for Astronomy, Episode 1 of 15. You have probably multiplied a NumPy array by a constant, but if you accidentally mix meters and kilometers in a complex equation, Python will not warn you, and your final array will just contain the wrong numbers. Letting the library handle the physical dimensions automatically is exactly what this episode covers. We're looking at the heart of Astropy, units and quantities. Astropy handles physical units through the quantity object. A quantity binds a number or an array of numbers to a physical unit. Because a quantity is a direct subclass of a NumPy ND array, you do not lose any performance or array functionality. You can slice, broadcast, and run standard NumPy mouth functions on them natively. They behave like normal arrays that just happen to know what physical property they represent. To create a quantity, you import the units module from Astropy. Then you simply multiply your number by the specific unit object. 3 multiplied by units.parsec creates a quantity of 3 parsecs. Many developers assume this abstraction is slow, which is a common misconception. It is true that multiplying a massive NumPy array by a unit object creates a new copy of that array in memory. To avoid this overhead, Astropy overrides the bitwise left shift operator, which looks like 2 less than signs. Put your existing array on the left shift operator in the middle, and the Astropy unit on the right. This attaches the unit to the array in place without copying the underlying data. Here is the key insight. The library evaluates the mathematical relationships between units as you compute. Suppose you want to calculate the travel time of a spacecraft. Your distance is 3.0 parsecs. Your speed is 130 kilometers per second. You create a quantity for the distance and divide it by the quantity for the speed. Astropy returns a new quantity for the time. It handles the division of the values, and it calculates the resulting unit, returning parsec seconds per kilometer. That resulting unit is mathematically correct, but not very helpful to read. You can change this using the to method available on every quantity. You call the to method and pass in your target unit, such as units.year. Astropy verifies that the source and target dimensions are both units of time, performs the internal conversion, and returns a new quantity expressed in years. For quick standardizations, you can also access the .si or .cgs properties on any quantity to immediately convert it to the base units of those systems. When you perform math where the units cancel out entirely, like dividing meters by centimeters, Astropy returns a dimensionless quantity. The unit still exists under the hood as an unscaled, dimensionless type. If you need to pass this result to an external library that expects standard Python floats or plain NumPy arrays, you extract the raw number using the value attribute. Before you extract any final value, remember that you can always simplify messy combined units down to their absolute fundamental physical dimensions by calling the decompose method. If you would like to support the show, you can search for devstories.eu on Patreon. It helps us keep making these. That's all for this one. Thanks for listening, and keep building.